This lesson deals with everything related to the second derivative. Okay, so we have things related to the first derivative, so that's critical numbers, that's relative mins and relative maxes, that's increasing and decreasing. That's all related to what we can do with the first derivative. What we can do with the second derivative is we can talk about concavity of the function. So I will always go to a picture because I think pictures are better. There is a typo here. I forgot to make this an exponent. So it should have been an x squared, as you can't even see what it is. This should have been an x squared minus 1. For what I type in Adobe Illustrator, all of your guys' notes. I have to manually change the superscripts and the subscripts after I type them. So that's why you'll see weird typos like this. That's because I forgot to go back and change it. Okay, so I like this picture. It's not in color on your paper. I feel bad. But I wanted you to see this. So here's a graph of a function. We would say that this area right here in the green is concave up. So concave up would mean that my second derivative was bigger than 0. And here in pink, we would say that this is concave down, where my second derivative is less than 0. In the midpoint, so the middle point of where I change from concave up to concave down, or vice versa, we call this a point of inflection. And this is where my second derivative is either equal to 0 or non-existent. So either equal to 0 or the derivative does not exist. Something else that you can know about the second derivative is that, and you'll see this as we go into other parts of this section, is even though we're not saying anything about the first derivative, technically this looks like a relative minimum. And at my relative minimum, we could say that that exact point of that relative minimum was on a concave up interval. Likewise, this would be like a relative maximum, and we would say that this relative maximum was on a concave down interval. So I could use the second derivative to tell me whether or not a relative min or a relative max was actually a max or a min based upon looking at the concavity of the function. Okay, so when I look at examples, there's a lot of pictures and stuff. But when I look at an example and I want to find points of inflection and concavity, we'll first just take a few derivatives. Now, the whole idea of relative mins and relative maxes and using that second derivative is actually called the second derivative test, which is in the second example. So if I want to determine points of inflection, I'm going to first, step 1, I'm going to take a first derivative. So I want f prime of x. So what's f prime of x equal to? 4x cubed minus 12x squared. I'm then going to take a second derivative. So my second derivative is 12x squared minus 24x. I'm going to set this equal to 0. And I'm going to factor out a common factor of a 12 and an x. And so when I solve, I get x is equal to 0 and 2. Because I want to look at the concavity of the function, what I want to do is set up a chart like I did for the first derivative. Now, these two values here are what we call possible points of inflection. They are only possible points of inflection until you test concavity. The only way it's actually a point of inflection is if it goes from concave up to concave down, or concave down to concave up. It has to change from up to down or down to up. Otherwise, it's not a point of inflection. So I'm going to do my chart. I have no closed interval that I'm bounded on. So I'm going to go from negative infinity to 0, 0 to 2, and 2 to infinity. And then I'm going to be super happy compared to the last lesson because now I can pick whole numbers. I'll be sad the next example question though. So I have negative 1, I have 1, and I have 3. So f double prime, I'm plugging it into, again, I would plug it into my factored version. I get a negative 12 and a negative x minus 2. So that would give me a bigger than 0. My 1 would give me a positive 12 and a negative x minus 2. So that would have been an f double prime is less than 0. And then 3 makes everybody bigger than 0. So my chart was around the second derivative. So it has changed from the previous lesson. It's now the second derivative. So now f is concave up, then f is concave down, then f is concave up. So step 3 was my chart. Step 4 is I'm going to figure out what f of 0 is equal to and what f of 2 is equal to. So f of 0 is 0 to the 4th minus 4 times 0 cubed. And then f of 2 is 2 to the 4th minus 4 times 2 cubed. So f of 0 is 0. F of 2, if you wanted to do the synthetic division way, you'd have your 2, you'd have 1, you'd have negative 4, then you have a 0 for your x squared, a 0 for x, and a 0 for your constant term. So you would have to write out all your zeros to get the right answer. Oops. So f of 2 is equal to negative 16. So now I'm going to write this as one big conclusion. So f is concave up on the interval from negative infinity to 0, union 2 to infinity. F is concave down on the interval from 0 to 2. And then f has points of inflection at 0, 0, and to negative 16. Okay. Questions? So let me be clear about something because some of you guys are making this error. So you only use the union notation when you're talking about intervals of values. If I'm talking about coordinate points, then it has to be like and, or you have to put a comma in between. You can't use the union symbol. The union symbol is only for sets of numbers. Okay.
What is this? Why do we want to know this?
Why do you want to know what?
Concavity.
Because ideally, everything that we're doing right now is characteristics of a graph so that I could draw the graph without actually graphing it in a graphic calculator or picking points. Because I could be able to create a sketch.
Was this the original of that original green graph?
Yeah, that's this one.
Yeah, that one. Was that the x squared minus 1? Is that what that was showing us? Or was that just a generic graph?
That is the f of x related to that derivative of x squared minus 1. Because this was labeled as the derivative.
Oh, okay. Wait, that's not right. Say that again? Please.
Huh?
Can you say that again, please?
This x squared minus 1 represents the derivative. That is the derivative of this graph. Because if I had an x cubed, its derivative would be an x squared.
And was this an x cubed?
Yes, that is the picture of an x cubed graph.
1, 2, 3. Yeah.
Okay. Other questions that you guys have? So I'm going to cross out this part. It was supposed to get deleted, but it did not. And then there should be, so I cross out the first chart, not the second chart. And then there is a typo because it will not work out the way that I want it to work out. Unless this was negative 3x to the 5th plus 5x cubed. So that squared and the exponent at the very last term should be a cubed. Okay. So I want to use the second derivative test. The second derivative test, what it tells me is relative mins and relative maxes. So it tells me relative extrema based upon looking at the critical numbers and figuring out whether or not the function is concave up or concave down. Okay, so my step 1, I'm going to find my critical number, so I'm going to take my derivative. So what's my derivative equal to? Negative 15x to the 4th plus 15x squared. I'm going to set this equal to 0 because I'm going to figure out what my critical numbers are. And I have a common, I'm going to pull a negative 15x squared out just because I like it better. I always like my x term to be positive if I can. And then my x squared minus 1 factors some more. So my critical numbers that I have are going to be negative 1, x equals, I should write it as x equals negative 1, 0, and 1. Okay, so what I want to know is x equals negative 1, 0, and 1, are those relative mins or relative maxes? Now, the foolproof way of doing it is by doing the chart that we did in 2-5 and 2-6. So to actually go through and do a first derivative chart and figure out where it's increasing and decreasing is the foolproof way of doing maxes and mins. But I could use what we call the second derivative test. And there are certain situations, like your end question will be 2C, where I will ask you to actually use the second derivative test. In that type of a situation, when you have implicit differentiation, the only thing you can use is the second derivative test to tell me whether or not something's a min or a max. You won't be able to use the first derivative test, okay? Unless you really want to go through the process of finding out what your values of y are for every corresponding critical number. It's faster to do the second derivative test instead. Okay, so what does that mean? First of all, so my second thing is that I'm going to find a second derivative. So what's my second derivative equal to?
4, 6.
So negative 60x cubed and plus a 30x. And I like it in the factored version because I'm going to just need to know whether or not I'm positive or negative. So I'm going to factor it out just because it'll make life a little bit easier. So really what I want to do is I want to take the second derivative and I want to find f double prime of -1. I want to find f double prime of 0. And I want to find f double prime of +1. And if I can figure out concavity at those values, I can determine whether or not it's a min or a max. Now, the only issue that we will run into is if the second derivative that I get is equal to 0. Because then I can't tell whether or not it's concave up or concave down because I got 0 instead. So when I plug in my -1, -30 times -1, 2 times -1 squared minus 1, I'm going to get something that's bigger than 0. Okay, so the second derivative being bigger than 0 means f of x is concave up. If I have concave up, right, then that means that I would have a relative minimum. A lot of theory goes into this question. Okay. Questions so far? So if I look at 0, 0 is going to make everybody sad. -30 times 0, 2 times 0 squared minus 1 gives me 0. Sad face. Can't do anything with that one. In theory, the second derivative test just fails there. So then what happens here? -30 times 1, 2 times 1 squared minus 1 gives me less than 0. So that means, since my second derivative is less than 0, f is concave down. So it looks like a frowny face parabola, which means f has a relative max. So I would have to figure out the corresponding y values, but we won't do that yet. We will, step 3 will be dealing with the fact that 0 gave me 0. When 0 gives you 0, you have to do the chart for the first derivative. This is why I'm not a big fan of the second derivative test. I only use it when I have to. Because if it fails, I have to show why it may not be a relative min or a relative max. So, because my critical numbers sandwich my 0 between -1 and 1, my interval here can only go from -1 to 0 and 0 to 1. I can't go outside -1 and +1. I have to stop it in that interval, which is very unfortunate because I had to pick a fraction. And nobody wants to pick fractions. So we only do step 3 when f double prime gave me 0 for some value of x. Okay. So my first derivative is somewhere. negative 15x squared, x minus 1, x plus 1. Okay. So I'm going to plug in my negative 1/2. So if I have a negative 1/2 in for my x, that gives me a negative here. Negative 1/2 gives me a negative here, and it gives me a positive there. So that means that overall f prime is bigger than 0. When I plug in x equals 1/2, I get a negative and a negative and a positive, so that overall I get bigger than 0. So f is increasing, and f is increasing. So my conclusion would have to now find, I want to find f of negative 1 and 1. So that's what? Negative 3x to the 5th. And then it was 5x cubed. So that gives me a negative 3 plus 5, which gives me 2. This would be a negative 3 times negative 1 to the 5th, plus 5 times negative 1 cubed. So this gives me a positive 3 and a minus 5, so that gives me a negative 2. So now I have to write one big conclusion. F has a relative minimum, we said, at negative 1, comma, negative 2. And f has a relative max at 1 comma positive 2, and at 0 0 f doesn't have a relative maximum because they were both increasing. Questions that you guys have? So the question I want you to do for the end question is going to require you to do 2A first. So you have to do 2A first in order for you to give me 2C. You might have to show me tomorrow or Monday if you're on the college trip. Okay? All right.